What'd you get, Davis? 34,800,000. Would you agree? So we gotta go 1, 2, 3, 4, 5, 6, 7. That's our new decimal point. And 1, 2, 1, 2, 3. I would have to agree. Nice work. All right, what about letter B? We have 2.1 times 10 to the 5th. What have you got, Lauren? 210,000. 1, 2, 3, 4, 5. I would have to agree. Awesome. What about 5.5 times 10 to the negative third? What have you got, Turner?
0.00 or 0.0051.
All right, so let's check. 1, 2, 3. Looks good. 7.6 times 10 to the negative fifth. Oops. What have you got there, McKenna?
0.000076.
Did I get enough zeros on there, kiddo? One more. So then we'll just do this. All right, so we've got 1, 2, 3, 4, 5. 1, 2, 3, 4. Awesome. Good work. So now I'm going to offer you, do you want to do more practice with these, or are you ready to move on? So here's what I would like to see. If you're ready to move on, give me a thumbs up. If you would like more practice, give me a thumbs down, because it's easier, it's opposite. All right, so it looks like we're all thumbs up. Awesome. Then we're going to start you on your next project. It's not really a project, it's kind of like the other timeline. You know how the last timeline you did was linear? The timeline you're going to do now is in a calendar form. Okay? And I'm going to show you how you're going to make your calculations. So let me go ahead and pass out. Let me go ahead and pass out this part. As far as you mean, how long will it take, or how long of paper is it? Oh, it's not. All right. You know how the last one was really, really long? Like, it was longer than Davis. It was longer than Colin. So it became
Only
kind
by
of.
a millennia.
Oh, please.
A millennia?
A good,
What?
a good foot.
I mean,
Yeah.
Only
an
by
eon, an eon.
An
that's
eon,
what it
only by an eon, okay. It became kind of unwieldy, right? Because it was so long and you had to fold and fold and fold and fold. Well, this time we're going to take the history of the earth and we're going to put it into a calendar year. So think about a calendar. This is what a calendar looks like, right? It's about an 8 by 11 sheet. So we're going to take the history of the earth and we're going to put it into one calendar year. And we're going to use scientific notation to do that. And you're thinking, oh, that's why she made us do that crazy stuff. All right. There's more than just this one page, but we're just going to start with this one page. Let us start in the upper right-hand corner because that's the easiest place to start. Different sources will give you different ages of the earth. So some sources say 4.6, some sources say 4.5. It's more closely like 4.57. So if it's 4.57 and you round to 4.6. But not every place rounds. So on this case, we're going to look at it as 4.5 billion years old. We're going to start in this corner right here. What we have to do is convert 4.5 billion years to a day on the calendar. Okay? So we're going to start with 4.5 billion years. Okay, now how are we going to do that? Because we got to do it in scientific notation. So 4.5 times 10 to the, Olivia?
I just had a question.
Yeah.
Is it 4.5 billion or 4.5 million? Because you're saying billion, but it says million, so I'm confused.
This is 4,500,000,000.
Oh, okay.
So 4.5 billion would be how many zeros are we talking, Davis? 9. So we've got 4.5 times 10 to the 9th. And how many days are there in a calendar year? Oh, 365. So we're going to take this number times 365. And for this activity, they're calling the Earth 4.5 billion years old. So our formula is going to be the date up here, 4.5 times 10 to the 9th, times 365, because there are 365 days in a year, and we divide that by the age of the Earth, which is 4.5 times 10 to the 9th. Now, what do you notice we could do right away? Lauren.
Isn't it like cross cancel?
Yeah, we can cross out because these two numbers are the same, right? So we could cross these out because 4.5 times 10 to the 9th divided by 4.5 times 10 to the 9th equals what?
0.
Doesn't equal 0, it equals 1. So then what would 1 times 365 be? 365. So this is 365 days. If you think about it, 365 days in a calendar year would be where? Well, if we start at December 31st and we count backwards 365 days, where do we end up? January 1st. So this is January 1st. So in our calendar starts on January 1st. That one's the easiest one. So now we got to go down to this one. The first fossils, 550 million years ago. So how would I write 550 million in scientific notation? That's the first step. 550 million. We know it's got to be a 5.5 times 10 to the what? To the 6th? To the 7th? If this is billion at the 9th, 550 million would be to the, Lauren, to the 8th. So if we have 4 billion, 500 million, right? And this is to the 9th, and then I'm just going with 550 million. That's got to be to the 8th, okay? How many days are there in a year? So I'm going to multiply this number times 365. How old is the Earth? 4.5 times 10 to the 9th. Now we do the math. Okay. In a minute, I'm going to teach you a little shortcut. Okay, you ready for a little shortcut? You know how we crossed these two out because they were identical? We can do something similar to this. But we can only focus on, or we're only going to focus on, the tens. We're only gonna focus on the tens. So what is the difference between 10 to the 8th and 10 to the 9th? What's 9 minus 8? 1, right? So that means 4.5 times 10 to the first would be equal to what? 45. Okay? So what I'm going to do is I'm going to end up taking 5.5 times 365 divided by 45. Is this right here more manageable? Definitely. So pull out a calculator and see if you can come up with an answer. There's one on your computer if you don't have an handout. Got an answer, Mia? Yeah. Got an answer? Share your answer with someone that's around you. Share your answer with someone that is around you. See if you guys got the same answer. If you did not get the same answer, talk about it. Figure out why. What did you do differently? What kind of answer did you guys come up with? Sophia, what'd you get?
44.61.
Okay, so we have a 44.61. Anybody anything different? All right, so here's what we do in this case. It's a 44.61, but in this example, in this activity, they do not round. So where it says calendar date, you would actually count back 44 days ago. What date do you start on? You don't start on January 1st. You start at December 31st and count back 44 days. Okay? So you start at December 31st and count backwards 44 days. It's going to be somewhere in